In this section, we're going to talk about the cost, revenue, and profit. And if you recall, in the previous unit, we talked about the cost, revenue, and profit using linear models. In this section, we're going to talk in particular about the revenue and profit using quadratic models. Okay, now before all that, let's talk about something that we all know and some of us love, the movies. So a movie theater charges $13 per ticket and sells an average of 934 tickets per night. Okay, now as you're doing this, make sure you follow along with your media notes and fill them in, please. Now, $13, it represents the price of the ticket. Okay, you go to the movies, you buy a ticket, it's $13. So $13 represents the price. 934, so the movie theater is selling an average of, so an average, by that we mean maybe on Tuesday they're selling fewer tickets, on Friday and Saturday they sell more tickets, but on average they sell 934 tickets per night. So 934 represents the quantity of tickets that consumers are buying. Now we're going to think of quantity in another way. Okay, we're going to think of quantity as the market demand. Okay, so what does the market demand mean? Well, in general, market demand is a consumer's desire and willingness to pay for a commodity. Okay, so in this case, consumers are willing to buy 934 tickets on average per night, right? So the demand for tickets is 934. So the demand is how many units of a particular commodity are consumers willing to buy. And in this case, the demand is 934 because that's how many tickets on average consumers are purchasing on a nightly basis. Okay, so we're going to think of quantity as demand. Now, the revenue of the movie theater. So the revenue is how much money the theater is bringing in, right? So they're charging $13 for each ticket, and they are selling 934 tickets each night. So the revenue is going to equal to 12,142. Okay, so now remember, revenue is not the same thing as profit. Profit is revenue minus cost. The 12,142, that's just how much money is coming in. All right, now you know what happens every couple of years? Movie prices go up. Like when I was in college, in high school, tickets cost like $4. And then as time progressed, to my horror, they went up to $13 per ticket. And now, the prices are probably going to go up again. So we're going to look at that scenario. So in our new scenario, the movie theater now decides we're going to raise prices. Okay, and so when they raise prices, the price goes from $13 per ticket to $15 per ticket. Now, when I was in college, in high school, and tickets were $4 per ticket, I used to go like twice a month, right? But when tickets started going up, now they're $13, I go like twice every 6 months. To me, it's not worth it to go every single week or every single month even. So as a price goes up, the demand goes down, the demand decreases. So as the price increases, the demand usually decreases. So fewer people are going to the movies now that the movies tickets cost $15. So the movie theater now sells an average of 821 tickets. So the price of the ticket is $15 and the demand for tickets is 821. The revenue is price times quantity. So how much money is the movie theater bringing in? Well, they're charging $15 per ticket, and they're selling 821 tickets. So the revenue is going to equal to 12,315. Now this is great for the movie theater because their previous revenue at $13 was 12,142. By increasing the ticket price, even though fewer people are going, they're still making more revenue. The revenue is 12,315. Okay. Now, because price and demand are related, as price goes up, demand usually goes down. As price increases, demand usually decreases. We're going to talk about something called the price-demand function. or it's also referred to just as a demand function, but we're going to refer to this for now as the price demand function. Now the price demand function, it relates the price of a commodity to its demand. It relates the price to the demand. So what happens as the price increases? Usually the demand decreases. On your first example, it says the price demand function of producing ice cream is given by the following. Is given by P equals to 106 minus 4x, where P is the price per unit of ice cream and X is the demand or quantity that consumers are purchasing. In part A, we want to calculate the revenue function for this company. So let's think about this. Revenue is price times quantity. So the revenue function, revenue in terms of X, is given by the price. Well, we have the price demand function, which is 106 minus 4x. So the price is given by 106 minus 4x. But what's the quantity? Now remember, the price demand function of producing ice cream is given by P minus 106, P equals 106 minus 4x, where P represents the price and X represents the units of ice cream sold, or the demand. So if this is the price, then the quantity of ice cream sold is going to be X units. So we have the revenue is equal to the price times the quantity. Okay, now let's distribute the X. So we're going to get the revenue equals to 106x minus 4x squared. Okay, that's part A. In part B, we are given the cost function. So the cost function of producing X units of ice cream is 10x plus 3. Using this, we want to calculate the profit function. Now, if you recall, profit is the revenue, how much money is coming in, minus the cost, how much is it costing to produce certain units of a commodity. Okay, so in this case, our profit, P of X, is going to be the revenue, which is 106x minus 4x squared, minus the cost, which is 10x plus 3. Okay, so we have profit equals to the revenue minus the cost. Let's simplify this. So the profit in terms of X equals to 106x minus 4x squared. Let's distribute the negative. We got negative 10x, negative 3. Let's write this in standard form, combine our like terms. So profit in terms of the number of units sold of ice cream is given by negative 4x squared plus 96x minus 3. Okay, this is going to be our profit function. Now, what do we want to do with profit? Well, most companies, they want to maximize their profit. Okay, so now we want to figure out how many units of ice cream must be sold, what quantity of ice cream must be sold, or how many units in order to maximize the profit. Okay, so in part C, we want to maximize the profit. In our previous lesson, we learned that the maximum or the minimum of a quadratic function occurs at the vertex. How do we calculate the vertex? The x-coordinate is given by x equals to negative b over 2a. Okay, the x-coordinate of the vertex is given by x equals to negative b over 2a. So what are our a, b, and c? Just so as a quick reminder, a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant. So if we're going to look at the vertex of this quadratic function, it's going to be negative b, which is negative 96, divided by 2 times a, which is negative 4. So this is going to give you negative 96 divided by negative 8. That means this company must sell 12 units in order to maximize their profit. Now keep in mind, you have to remember what each variable represents. X represents the demand or the quantity of units that are sold. So the company has to sell 12 units in order to maximize their profit. Okay, now the next part of this question says, what is the maximum profit? Well, if we know that X is 12, we can plug it in to get profit. So P of 12, so the profit when 12 units are sold, that's equal to -4 times 12 squared plus 96 times 12 minus 3. Now we've practiced this quite a lot of simplifying this and getting a value for that. So remember to do the exponent first and then multiply, then add, subtract at the very end. But the profit when we sell 12 units is going to equal to $573. And that is going to be our maximum profit. You sell less than this, then the profit is lower. You sell more than this, profit is also lower. Okay? And now in part D, what should the company charge per unit to maximize the profit? So we're looking for the price. What price must the company charge in order to maximize the profit? So let me get rid of all this. Okay, so in part D, we know that the value of X is 12. When 12 units are sold, the profit is maximized. So what is the price when we sell X units? Well, the price, which by the way is different than profit, is going to equal to 106 minus 4 times 12, because selling 12 units maximizes the profit. So we're going to get P equals to 106 minus 48, and that'll give you $58. So if you price 1 unit of ice cream at $58, so we're looking at some like big container of ice cream. We sell 1 unit of ice cream at $58, then we will sell 12 units of that, and our maximum profit will be $573. Let's look at the next example. Next example states, the price-demand function of producing designer dog leashes is given by P equals 38 minus 2x. Where P represents the price and X represents the units of dog leashes that are sold. So number of dog leashes that we're selling. Okay, so part A, it says calculate the revenue function. Now we know that revenue is price times quantity. So the price demand function, or the price, is given by 38 minus 2x. At this price, what's the quantity of dog leashes that's being sold? Well, the price demand function relates the price to the quantity. So if this represents price, X represents the quantity. So the quantity is just going to be X. Okay, so the revenue, if you distribute the X, we're going to get 38x minus 2x squared. Okay, part B. We want to calculate the profit function given the cost function of producing X number of dog leashes is equal to 10x plus 7. So the profit function of producing X number of dog leashes is given by the revenue, which is 38x minus 2x squared, minus the cost, which is 10x plus 7. Okay, so our profit is going to be 38x minus 2x squared. Let's distribute the negative. We have a negative 10x and we have a negative 7. Okay, so the profit is, if you write this in standard form, we have a negative 2x squared. Then we got 38x minus 10x, which is going to be 28x minus 7. Okay, so this is going to be our profit function with respect to the number of dog leashes that are sold. All right, part C. How many units must be sold to maximize the profit? So in part C, remember the maximum or the minimum of a quadratic function occurs at the vertex. The x value of the vertex is given by x equals to negative b over 2a. So we have, in this case, our b value is 28, so we have negative 28. Our a value is negative 2, so we have 2 times negative 2. This gives us negative 28 over negative 4, which will give you 7. So we have to sell 7 units or 7 leashes to maximize our profit. Now in part D, we have to figure out what is the maximum profit. So if the value of x is 7, that means we're selling 7 units, then P of 7, which represents a profit when 7 leashes are sold, is going to be negative 2 times 7 squared plus 28 times 2 minus 7. Okay, so remember exponent first, then you multiply, then add and subtract at the end. And the profit when 7 leashes are sold is going to equal to $91. Now this looks like a pretty low profit to be made, but maybe the company is just starting out. Maybe just someone who's like selling through Etsy or whatever. So sometimes this happens where when someone is first starting a business, their profit is very low. Okay, now in part D, what price should the company charge per unit in order to maximize profit? Well, we said that 7 units maximizes our profit. So what is the price when 7 units are sold? So price is going to be 38 minus 2x, which is 2 times 7. That's going to be 38 minus 14. So the price of each dog leash is going to be $24. And a price of $24 per dog leash is going to sell 7 units, which will maximize our profit at $91.